Okay. Should be good to go. All right. So first things first, some logistical details. We're going to have the link to the README down here in the bottom left of every slide, so you can always get access to that. And then this QR code here will also give you access to the slides. And this QR code here is very important. This is the sign-in form. The reason why this is important is because we're planning to give you guys food at future meetings, and we need to get a head count for that. So it's very short. So I strongly recommend filling this out so that we can do that. I'll give you a couple of minutes just to kind of, or a couple of seconds just to kind of get it. And then try to fill it out as we go at the end. Yeah, any questions on this? Okay, great. Yeah. Okay, sorry. Good. Okay. Okay. Yeah, if you get the slides, you get the QR code. So. Okay. All right. So on the subject of free stuff, bag of candy there. So if you attended Stacks Tool, you might be familiar with the kind of thing that we tried to do there with tech tokens. So we've kind of adapted that. This quarter, we're going to do a thing where basically, if you ask a question, you get candy, and if you answer a question, you also get candy. So does anyone have any questions on this? Okay. No candy then. Let's hope we give candy. Oh yes, go ahead. Petals, Star Wars, and Earheads. Which one would you like? Go on. All right. All right. So another logistical detail here. If you guys want to follow along with the demos, we're going to be doing like 2 to 3 demos every workshop. You're going to need to create an AWS account because we're going to be using AWS as a kind of cloud provider that we're going to do examples. So in order to do that, you can click on this link here or look up like AWS console or AWS account and then create one. It should take less than 5 minutes. But a little caveat there is you will need to enter in payment details. But nothing that we do will use, like will cost you anything. Everything is within the free tier. And everything that you do on the cloud, if you're using one of those free tier accounts, will be upfront about if there's a cost. So everything we do, once again, will be well within the free tier. So you don't have to worry about paying after. All right, any questions on following along? Okay. So then I'm going to pass it on to Caitlin to do the info.
Alrighty. So first, we're going to be doing a little workshop series overview, and hopefully that'll answer some of your guys' questions about what services we're going to be covering. Then I'm going to introduce cloud computing to you guys. We're going to do a demo on Amazon Web Services. We're going to talk about IAM, or Identity Access Management. We'll talk about Amazon Web Services, S3, blob storage, and then we're going to do 2 more demos in which we talk about versioning and buckets, and then we're going to deploy a static site with S3. So without further ado, let's get started. So first and foremost, what is HackCloud? Fortunately or unfortunately, depending on your interest, we are not hacking the cloud. We don't have the necessary legal representation to do that. But what we are going to be doing is we're going to be hacking some of the question marks surrounding cloud computing. We're going to cover what it is, why we use it, what we can do with it, and how we use it. And at the end of this quarter, you guys will hopefully have a strong intuition for how cloud computing fundamentals and best practices, and you guys will be highly familiar with and able to use AWS for all your project needs. So with that, today we're gonna talk about cloud computing and storage. Then next week, we're gonna talk about virtual machine computing. Week after is serverless computing, then DevOps and cloud, then machine learning, and then we're gonna round it off with some data science. And without further ado, up and away, adventure awaits. Okay, so now going into cloud computing. Why do we want to use cloud computing? Like, what is it? Why do we want to use it? And to answer this question, I'm going to illustrate with an example. Say Carl, our lovable, intrepid, balloon selling adventurer from Up, wants to expand his business horizons. So he wants to create a streaming platform called Paradise Falls, completely not ripping off Disney Plus. I did not get this from the Disney Plus site at all, don't worry. And so people are going to be able to watch shows and movies for only $9.99 a month. Exclusions apply and see store for details. But on top of that, to differentiate his business model from competitors, Carl's going to give you a customizable balloon for every show you watch. And I think that's pretty cool. Now, this is going to sound a little bit like a management class, but I promise this relates. What tech/tech capabilities does Carl need business? Do we have any ideas? Yes. Yes. We need user authentication. So that means we need to like track like who's accessing our site, and that leads into storage. We need to like store information about our users. Anyone else? Come on. Throw out ideas. Okay, next. What else do we need, Sadian?
Well, you need something to find, like to find your actual movie. If somebody wants to go to the site, they can just play your actual movie.
Yeah, so we need a server that's gonna take requests and like deal with them. And then in order to get to the servers, we need obviously network hardware to like take stuff like from your computer and then feed it over to your servers, and the server's gonna deal with everything. Okay, so we covered that. We need storage space to store films and shows and user data. We want servers to deal with requests from clients, and then network hardware to connect our servers to storage and to. So, okay. So first, okay, there are two ways that Carl can get these hardware, and we're gonna analyze these two approaches with 5 measures: cost, scalability, reliability, availability, and security. Now, I'm going to break that down for you. Cost, easy. Can we be Tony Stark? Oh, wait, do we have to be Tony Stark, or can we be Mr. Scrooge? Like, is it cheap? Is it affordable? 2, scalability. So scalability is the property of a system to handle a growing amount of the work. So you can think about this as how easily does our system adapt when it needs more resources than is currently provided. And you can also think about this as how easily does our system deal with increasing our coverage size, like geographically. So say we are just dealing with users in the LA area. Can we also deal with users in the entirety of California? Can we expand that to the entirety of the United States? Can we deal with it globally? Reliability. Can we trust this system with our data? Will we lose data? Will we get the correct data when we ask for it? And then availability. Will we wait a millennia to get an answer to our request? Hopefully not. And can we always count on there being a response? And lastly, security. This is very self-explanatory. How secure is our system? Will our data be protected when it's like going into the system and when it's being stored in there? So our first model is the on-premise model. And the first course of action Carl takes is that he, as in the business, can buy and manage all of the storage, servers, and network hardware. So if he has to buy all of this, can anyone, like, does anyone have any ideas as to like what's good or bad about that? Yes. Wait, okay, you first, because you haven't spoken yet.
Also needs to it's kind of like customize it. As a storage.
Actually, very much correct. That's a lot of upfront costs you have to like invest into buying hardware. You do get some customization, but I will really get. I will get back to you on that. Do you want like a Skittle? Airhead, I don't know. So a pro is actually security, because when like the on-premise model means that you have control over everything. Like nothing happens in the hardware that you do not explicitly allow. And so it makes it very safe. But this model does come with a lot of issues. That it is expensive. You have a large upfront cost of hardware, and when you like are maintaining it, it's very expensive to do so, and like you have to do it regularly in order to keep everything in good working condition. Unfortunately, it's not reliable, because if one of your components breaks, then your entire site goes down. And it's not available because people very far away from your server won't get their content quickly. And it's actually not scalable, because scalability means that you need a forecast where your system like needs to have access to ahead of time. So then you need to buy/rent the property in a different location, or even in a different country, and deal with the bureaucracy within to like set up a server and get a sort of hardware there. Then you need to buy the server's hardware, etc. You need to schedule downtime in order to install everything. And then you need to deal with the bureaucracy of managing it. And it's just insane, too expensive, and too chaotic. Does anyone have questions about the on-premise model? Nope. So it sounds like a whole hullabaloo. I was really proud of that pun. Can you guys laugh? Thank you. I'll take the pity laughs. Well, we can do better. So secondly, we can invest in cloud computing. So what does this mean? Well, it means functionally, we're yeeting all of the hardware to a trusted third party. So that would be Amazon's AWS, Google Cloud Platform, Microsoft Azure, et cetera, et cetera. There's like many other providers, but we'll be focusing on AWS in this case. Why? Just because. And in this model, we don't have to like buy any of the storage servers or network hardware, but we do have complete control over virtual compute instances, storage, and networking components, which means we click stuff on a website and the third party takes care of everything, and we like get our specified storage, networking, and instances. So we don't have to deal with any of the hardware stuff. Okay, can anyone tell me pros and cons of this setup? Yes.
Usually. They're all going to be very specific components, but they will be running up stuff on servers. So if their stuff's not secure and they don't properly manage it, so essentially if some third party doesn't have secure app on the cloud provider, then there's potential for cloud provider to become slow. It's real.
Okay. What more can you want? We are going to be perfect. Oh wait, yes, you. True, yeah. God damn it, okay. Do you want the mystery?
Sure.
Do you want? Okay, is that it? Good, okay. Oh, no. So yes, you're right. It is extremely cheap because Carl doesn't need to buy the hardware. He rents it from Amazon at a discounted price, and he doesn't have to deal with upkeep. And Amazon takes care of reliability if our system goes down. So we can trust that the site won't lose data and it won't go down for any old reason. If it does go down, I think we have wider problems than just Carl's site. And we also don't have a single point of failure that would occur from our on-premise model because we have a limited amount of supplies. And if those break, then we're in trouble. And Amazon takes care of availability because they have servers across the world, and we just select which one we want, easy peasy. We can get a location there. And it's actually very scalable because it's globally distributed. So you click a button and there you got a new server in a different part of the world. And so you can expand your reach globally very easily. Okay, so I mentioned globally distributed. Okay.
They also well. What is CM? What is there?
It's not only, I guess, AWS has, like most cloud providers have their own CDN. I think AWS is called like HackCloud or something. But essentially for those that aren't aware, the CDNs are just content delivery networks. So they just help with exerting content around the world faster. So let's say you want to use AWS, but you want to keep your content around the world, right? You could use a third-party CDN with your own on-premise service. That's kind of a
Yes. Okay. Okay, so I was talking about globally distributed. I threw that out kind of without a definition, so I'm gonna talk about it now. So Amazon obviously has servers distributed globally that you can utilize, but in order to use them, you have to specify an availability zone and region. So region is obviously a geographic area, but an availability zone is multiple isolated locations within a region. And local zones provide you ability to place resources really close to your customers. And so like when you have all these servers and storage areas really close to your users, then you can get requests answered really fast, and you can scale globally to distribute content and ensure that all users get like a really good, like smooth video experience. So profit. And also I placed the server on top of Paradise Falls because I thought that was funny. I think it's really sad that I crack myself up more than I make you guys laugh. But I had a good time making this slide, so. So yeah, Carl will definitely be using cloud computing because it sounds really good. And does anyone have any questions about that? Nor? Okay. Wait, but Mr. Fredrickson yells Russell. What about security? And you brought this up too. I didn't really mention security because yeah, it's really dicey in cloud computing. It's just like way too easy for other people to like get in and look at your data, especially if it's like the third party or like the cloud is like really easy to reach anyways. But we do have some ways of solving this. Does anyone have any ideas? It's okay if you don't. It's also great if you do. No? Okay. So first, they have the shared responsibility model, which means that both the provider and the customer share responsibility in ensuring security. So the provider basically secures the cloud. They guarantee the hardware, OS, and data center integrity and network connections, etc. And the customer actually is responsible for anything on the user side. So they take care of anything that accesses the cloud, and they provide data encryption on all data going. And secondly, they have the principle of least privilege. In identity access management, they use the principle of least privilege. Satyan's going to talk about this a little more, but I'm going to tease it a little bit right now. So basically, we don't want everyone having equal access to our data. So the first step is to deny everyone access to everything. You may not touch it unless you are the creator. And then we build access permissions on top of that. Who here has taken CS35L? All right, that's almost everyone. Then you guys should absolutely know this. Who here is familiar with file? All right. Oh, okay. How about file permission and like
permission to access. We're talking about a Unix-based system. Most cloud computers are Unix-based systems. We have the user, group, and others. And we have file permissions that read, write.
we execute, right?
We might execute.
Okay. What does
Reading is just being able to see the file. You can have several people being able to see the file at the same time. But you cannot change the file.
right? You want them? You want Skittles, Airheads, Starburst? Skittles, awesome. All right, who wants to explain what right? Yes.
So basically, write text means that when you have a file here, you have write permissions. It means you can actually modify the file's content.
Yes. Exactly. Do you want what can you want?
I guess about Skittles.
All right, and so does anyone want to explain?
So basically, if you allow to execute the file, you can run it, but it doesn't necessarily mean to change it. So this permission will.
A plus, gold star. Candy? Okay. Would you also like to be the product of the flavor I give you? Green?
Great. Great.
Okay, is anyone confused by that? I'm gonna assume that's a no, okay. So, what, like, you guys were absolutely correct in that you get like all of these different accesses to a file based on like who you are, or like what group you're part of, because you want to protect file security, right? So the same thing is gonna happen in with like the cloud computing, because you only want certain people to be access the data in the system in a certain way. I will say that cloud permissions are not exactly like one-to-one with like file permissions. So they might have like more permissions, or they might not even like include the idea of like read or write, or but like same principle. And like by doing so, you decrease the chaos here that would happen if everyone was able to access. So cloud computing for the win. I included a few statistics in case you guys just weren't convinced by me. So AWS is actually the most popular cloud service globally, followed by Microsoft Azure and Google Cloud. This is like the market share of all of like the top three and like the others, which actually makes us an oligopoly, AO. And 98% of organizations use cloud in some way. And this is expected to increase because it's simply a lot more profitable than the on-premise model. And if you're wondering why these numbers don't add up to 100, it's because like many companies use like a hybrid version, so like they use private cloud and public cloud or on-premise and public cloud. And so there's double counting in there. 6 in 10 CXOs like CEO, CFO, CTO, think that cloud computing improves security. And this is where I sound like a business major. So cloud computing is growing really fast. For those of you who don't know what market size is, it's the total revenue an industry makes, like across all the companies in an industry, how much are they cumulatively making? And so the cloud computing market size was valued at $405 billion in 2021. They're projected to grow to 1712 billion by 2029. And for reference, how many of you guys use like Netflix, Disney Plus, HBO, any of the above? Okay, I'm gonna assume it's a lot of you guys. So the market size of the video streaming on demand service, so that's like Netflix, Disney Plus, HBO, Hulu, whatever, it's only $95 billion. So it's easily like 4 times the size of just like this really popular application that we all use. Yeah, it's like 95 billion compared to 405 billion. Like right now, like it's kind of insane. And in case you guys want to know why I just threw that at you, my dad's been influencing me a little too much because he likes to talk business at the dinner table. And I thought that was cool. So yeah, how computing for the win. Let's enjoy baby Carl giving us a thumbs up. So now we're going to shift from overall benefits of cloud computing to the specific services that Amazon Web Service gives us, because it's not about what we can do for Amazon, it's about what Amazon can do for us. So here are some AWS service areas that like you guys might know or might like to use in the future. It's a lot of text, so you guys don't have to worry about the purple stuff because I love purple and Hack Purple is the thing. So they offer computing services like EC2. And if you're like me and on the job search, then you've heard of Kubernetes and wondered what it was, or maybe you know, and you're just that much more cracked than I am. So they have storage like S3 blob storage. They have databases like RDS, which is relational, DynamoDB, Redshift. If you heard any of those in 143 and are triggered, me too. There's networking, machine learning, analytics, security, and IoT, Internet of Things, which is really cool. And yay. Okay, so I've just gone over why cloud computing. We're going to hand it over to Sachin to explore Amazon Web Service.
All right, so yeah, do you have a question? Sorry, can you say one more time? You're gonna have to say that one more time. Oh, VPC. It stands for Virtual Private. VPC. Virtual Private something. I think I'll have to look it up. I'll get back. Basically, what it is it's like a concept of a virtual network between like different services in the cloud. So if I allocate like an EC2 instance and then a DynamoDB instance, right? So like a database and a computer, I would store like configure them both under the same network, and that kind of network is called a VPC. There you go. Yeah. Any other questions? Okay, great. So let's jump into the demo then for AWS. Hopefully you've created an account if you want to follow along. Otherwise, this will all be recorded so you can kind of follow along afterwards. So I'm just going to look up AWS console, and then we want to click on this link here, and then log back in. And then because I have an account, the details are already there, so I'm just going to click enter, and then use my autofill password. And a key thing here is that AWS strongly recommends using multi-factor authentication like UCLA does, and like everybody nowadays. So I have to enter in the code. But when you create your account, you will not have to, oh shoot, just changed. When you create your account, you will not have to set it up with multi-factor. It's optional. Okay, great. So this is what's known as the AWS console. It doesn't have a command line directly, which may make that word seem a little strange, but in the documentation, that's what it's called. The key things of note here are the service button in the top left. So if you click that, it'll open up two kind of submenus. The one on the left corresponds to the service area. So those are the purple words that you can talk about. And then on the right, these are the services that fall under those service areas. So those are the things that will influence. So for example, if I click on compute, we can see EC2 that I briefly mentioned, and we'll go into detail next workshop, is right there. Okay, any questions on that service menu? Services? Okay, great. So you can also use the search bar. So if I look up like EC2, it'll come up here, and then I can click on that and navigate to the dashboard for EC2. The next kind of main feature of the console here is this button here. So if I click that, it will provision what's known as the Cloud Shell. So this is just like a terminal in the cloud. Looks like it's taking a while, but the general idea here is that we can actually write code to interact with these services, as opposed to kind of going and clicking the buttons in the browser. The reason why that might be advantageous is because, like, let's just say I need to allocate 100 servers, right? I don't want to go and click 100 buttons and make sure that I didn't mess something up by like clicking or whatever. If I can like write a script just to do it and then run it, I can be sure that my allocation will happen the way I want it to. So this is the way that people with traditional, developers will traditionally work with cloud, using a console, or like they can use that console locally. They download the SDK. But for all purposes, we're just going to stick with the graphical interface. All right. Then the next feature here is this button. So this corresponds to current region that we're in. So like Caitlin mentioned, AWS is a globally distributed system. So it has data centers everywhere around the world. These are just some of the regions which they have data centers in. The default one is the first one, which is North Virginia. And then the last thing that I'll mention here is the account details. So if you click on this, it'll show my account ID, and then I can configure it. Okay, I know that was very quickly. I just want to be mindful of time. Does anyone have any questions on the console? Okay, great. Let's head back to the slides then, and we will continue on. Okay, skip past this. Okay, so now we're going to spend a little bit more time delving deeper into IAM. So this might seem a little strange, like why are we bothering? Like Hayden just talked about it, right? Why are we bothering to talk about this? Well, IAM is whenever you configure a new instance of any service, you need to configure it with IAM in mind. So going through this now will be helpful for all of our future workshops. So to kind of illustrate how IAM works with AWS and most cloud providers, we're going to go through a little example. So here, Russell wants to go visit Paul. So he shows up at his house, is asking if he can come in. But by the principle of least privilege, like Hayden mentioned, Carl says no, right? He denies access by default to everything. Okay, but to fix this, Carl can bring his little, Russell can bring his little great badge the next day, and can try to ask if he can come in again. So in this case, the badge serves as a form of kind of authentication, the proof that Russell does really have the ability to enter Carl's house. And now Carl's happy in that. Okay. So in our example, like the analogy is that the badge represents the notion of an AWS policy. So policy is basically just a set of permissions. So this would be like akin to those read, write, and execute permissions that Caitlin was talking about. AWS has their own kind of pre-made policies. For example, full access to a given service, only read access to a given service. They have pre-made policies, but sometimes you'll want to customize your own policy. So they have the ability to do that as well. Typically, they're written in what's known as JavaScript object notation syntax. So it is just a special format, nothing too fancy there. And we'll look at an example in a second. And then there are three main parts for all policy documents. There are also other optional sections, but these are the three that are required. So the first one, effect, this corresponds to whether the policy is like adding those permissions or removing the permissions. So it's either allow or. The second one is action. And that corresponds to basically the permissions themselves. So do I have readability for this service? Do I have writability for this service? And then the final one is resource. So it says within the service, do I have read, write, like whatever the permissions are? for a particular instance of that service. So we'll look at an example of policy document here, and hopefully that'll shed a little bit more light on that. So this is an example of a theoretical policy document corresponding to our scenario. Essentially, what that badge would be. So in our case, we're applying permissions to Russell. I guess we're giving permissions to Russell. So we want allow as the effect. As the action, we're basically specifying the specific permission that the badge gives. Namely, it's saying we can enter any house. That's the permission. But the problem with leaving it there is that the permission is very generic. It's not specific to an instance of the house. It's just saying for a house, you can enter. So that's where the resource field comes in, where we're saying, okay, this is the specific house, and then it calls house number 1, 2, 3, 4, 5. We've specified it in. So it's saying for this specific house, that's the only one that this policy actually applies to. Okay, so any questions on policy documents, format, or these 3 parts of them? Okay, great. So then now we can talk about once you've actually written up that policy document. In our case, we just gave it to Russell, and he was allowed to go inside. So this is akin to the idea of users in AWS. The name is pretty self-explanatory, right? So like in the cloud, if you want to give permissions to a person, you would apply it. The target of that policy would just be the user. Can anyone think of any other things that we might be able to give the badge to, and then let that have permission to interact with Paul's house? Or Russell? Yeah, Paul's house. Yeah, go ahead. Applications, yes, exactly. That's one of them that we're going to decide. That's the last one we'll talk about. What else? Do you have any other ideas? So another thing that Call could do, this one's a little bit nuanced, is that instead of wearing the badge himself, he can attach it to his little sash. So the idea behind that is if he's wearing the sash, he has access to Paul's house. But if he takes the sash out, he won't have access. So that might seem like the same thing, right, as the user thing. But the difference here is that he can give the sash to his friend, and then his friend will have access to the house, but he won't. So this is akin to the notion of a role in AWS. So this is a very popular way of doing IAM permissions. The reason why is because it aligns with the principle of least privilege, meaning I can choose to only assume the role when I need the permissions, and then I can give up the role when I'm done with my work. So that way I won't accidentally change anything when I'm working like before that or after that on something else. Yeah, go ahead. Yeah, so that would be akin to applying it to a different user. That would be perfectly valid. Yeah. Yeah, go ahead. Yeah, that's a good idea. It actually gets into the next thing here. So there's also a notion of a group in AWS. So you can define a bunch of users under a group. You can file a bunch of users under a group and then apply the badge to the entire group. And the idea there is that we have a single kind of notion of a policy that applies to multiple people. So we have a single place to change that policy when we need to add new permissions or remove permissions. Yes, go ahead. Yep. Yes. Yes. And you take the sash out, not the badge. Okay, great. And then the last thing here, you that mentioned for giving it to a service, you can give the badge to like a robot, for example, and then the robot will be able to walk into Paul's house. So the robot is like somewhat autonomous. In the case of cloud computing, you give it to a service. So maybe like a computer, a virtual computer. You can say, like, hey, I have permissions to write data to a database. Okay. Any questions on IAM before we move forward? Okay, great. So now we're going to talk about, I've shown it on the slides multiple times, but what do you think the simplest thing that we might be able to do in the cloud would be? Try to think about if you turn, yeah, go ahead. Yeah, that's pretty close. So imagine turning on your own computer, right? What's the simplest thing you could do on your own computer? Say that again? back it up? Okay, I mean, I would think that'd be kind of challenging. Like, how would you go about doing that? Okay. Any ideas? Simplest thing you could do, other than turn it off. I would say just create a file, right? You just like right click new file or whatever, and then you're done. So the first service that AWS came up with was called Simple Storage Service. And this is just a what's known as a blob storage or object storage service. So we'll talk a little bit about what that means in a second. But some of the goals of S3. So it's designed to be highly available, meaning if I upload some data, I can get it anywhere I want. Like security is a big thing. Performance, so I can download the data quickly. And then durability. This is the main one. They want to make sure that if you upload data, it does not get corrupted. So this is the guarantee that they give you that your data will not be corrupted, right? So that's like almost 100%. Okay, so like I mentioned before, it's an object-based storage. So that, oh shoot, let me just cover in some stuff. But this would be akin, like object-based storage is similar to like a file storage, which is what all your laptops presumably use. Except the difference is that it uses a flat namespace. So that means there's like a very large bucket basically, and we just put everything in. So the reason why this is good is because assuming we can kind of identify what we need very quickly, we don't have to traverse through a tree, like the tree of the file structure. We can just grab the object. Then theoretically with an object-based system as well, we have infinite scalability. So if we're running out of space in that large container, right, the flat namespace, we can just plug in an extra like storage device and then extend the storage. So this is what AWS would do if they're running out of storage. Like people just trying to upload data and then in order to meet some of these goals up here, specifically the availability one and durability one, AWS will automatically store your, anytime you upload a piece of data, it will automatically store it in 3 separate data centers redundant. So that's kind of how they're able to meet this durability requirement. And then on the off chance that all 3 of those data centers get destroyed, they also have this optional thing called region replication, where they're also stored in a separate country. This is that you have to pay a little more, but mostly this is for like compliance regulations. So if you need to make sure your data doesn't get corrupted, and it's required by the government, you have that option. Okay. Any questions on S3? Okay, so let's talk a little bit more about how the structure actually works. So we're going to go through an example where we want to store 4 image files. In this case, there's the notion of objects, which is just the file itself, alongside some metadata. So for those unfamiliar, metadata just refers to the concept of data about our data. So in our case, it would just be data about our file. For example, like a unique identifier for it, the author, the version number if we choose to update it later, and details like that. So when it was created, right? So theoretically, one might think, okay, we can just upload all these images and be done with it, right? But S3 also has this notion of a bucket and requires that all objects be stored in a bucket. So this prevents our global namespace from being super cluttered with a bunch of like hundreds of thousands of objects. So all objects need to be stored under a bucket. And a bucket is owned by an AWS account. So if I go into S3, I have to create a bucket, and then I can upload my images into that bucket. And I have ownership over that bucket, and no one else does, because the principle of least privilege. And then the bucket, kind of a weird quirk of the design of the system is that because it's in a global namespace, if I take the bucket, my bucket, nobody else in the world can take it until I give it back. Because like we mentioned, it's a flat global namespace. And then these are the requirements here for the bucket names. And then for simplicity, AWS also has this notion of a folder. So under buckets, you can create a folder, and then you can store your objects in those folders. So yeah, this enables organization. But this might seem a little weird, right? Like if we're using folders anyways, like a tree structure, how are we exploiting the fact that this is like an object-based, sorry, yeah, an object-based storage? Well, it goes back to how it's actually implemented versus the abstraction that they use for users. So let's look at this little example here. Here I have a big bucket, the blue box. This is my characters, and then I'm storing my dogs in the left folder and people in the right folder, and then I have the actual objects. down here, this dotted line below it, you can see the metadata, and then the object itself is here with the name. So the way that we'd actually store an image like this one here, Doug, is in our namespace, in the flat, like big buckets, the object would be stored as characters / doggos / dog. Like that would be the name that the object would have. So it's just a single name. And by doing that, by just concatenating the kind of path, we can still keep it in like one flat namespace. But kind of have the abstraction of the tree structure. Okay. Any questions on the actual? Yeah, go ahead. But oh, do they have metadata? Yes, they would. I think you could do it. You just have to go. We can check it out later. You just have to go to a different like kind of yeah thing. Any other questions? Go ahead.
So is there only
Yes, that's correct.
oh,
Yeah, a little bit. But there are ways to like if you don't want to use S3, there are ways to get around that, and you can always use like a domain name, like map an S3 domain to your domain name. But we can talk about that after if you're interested. Okay, let's move on then. So here we have another kind of important feature of S3, which is versioning. So the idea is that if you upload an image and then upload any file really, and then upload another version of that file with the same name, it will automatically replace the version, but it'll store the previous version as well, if you enable version. So this allows you to easily restore old versions, delete old versions, and like kind of handle that updating structure within S3 itself. Okay. And then S3 also has encryption, because security is a big thing for them that they want to make sure they address. So by default, as of 2023, security server-side encryption, which means that when you upload the data, S3 will automatically encrypt it and then store the encrypted version, is applied by default. That was not true in the past. In the past, you would have had to just check a box. But by default, that's true now. Yeah, the main thing here is that they're just trying to make sure that your data is secure when it's stored at rest. In-transit data protection, so this is like you downloading your data or uploading it, can be achieved by just making sure you're using HTTPS, which is just to say you're using SSL or TLS. If you take 35L, I think they talk about this, and then the networking class probably talks about it as well. But this is just a way to connect to a remote server securely. Okay, any questions on encryption? Okay, so we're going to quickly run through some additional features here. Okay, there we go. So one of the main features of S3 is that it has this notion of storage tiers. So like I mentioned before, S3 is really good for storing, like meeting compliance regulations. So like storing a lot of like archival data. So the way that they can kind of help cater to that more is by having different tiers of storage, with the farthest over there costing the least and the standard tier costing relatively the most, but still very cheap. So the idea is if I'm not going to access my data very frequently, I can store it in a lower tier, knowing that I won't have to pay as much because I won't access it a lot. And then there are also these things called lifecycle rules that allow you to transition between those tiers. S3 also allows for multi-factor deletes, so nobody, like people can't go and delete it and then just like be done with it. They have to delete it and then make sure that they can verify it externally. And then, like most services on Amazon, there's a notion of logging, monitoring, and analytics built in. Yep, go ahead. Yes, so the idea is like, let's just say I upload my picture of the dog, and I want to delete it. Now, my friend wants to screw me over and delete it, right? So he opens up my account and he tries to delete it. I'll get a notification on my phone and I have to say, yeah, okay, delete. So he won't be able. Okay, so now let's think about some S3 use cases, right? Like when would we want to use? I kind of mentioned a couple of things, and these images should. I tried to pick them to be hints, except for this one, which is just fine there. But yeah, what do you guys think? What might be some cases where we'd want to use S3? Try to think about the storage tiers. Why do those exist? Yep, go ahead. Yeah, great. That's exactly right. That's one of the great use cases of S3. If you remember what the demo that we're going to be doing, in the interest of time, I'll just go through it. So a great use case is data backup. So if I have a computer that I want to make sure I back up the disk, I guess, I could do that through S3, especially if it's a computer that I'm running through Amazon, because I mean, like the services are interconnected. Hosting static data, so this means like websites, images, videos. S3 is great for that. We're actually going to host our own website later on. Most of you presumably use Gradescope. Gradescope is actually built on S3. So if you look at the URL when you open up another file, you'll see it should say amazon.com/whatever. And it'll probably have the bucket name there. And then file sharing, S3 can be used to share files between different Amazon accounts and across the internet. Just like if we want to post a website, we have to share it, right? And then we have infrequently accessed data and archival data. And then if we want to integrate with any other service that involves using a lot of data, like machine learning or data, other data services, you're more than likely end up using S3. Okay, so I know I went through that quickly. Any questions? Any last questions on S3 before we go into the demo? Not necessarily. So the idea is that if I create a bucket, I'm the only one with access to it. But I can share that bucket with somebody else by giving them one of their badges, right? Giving them applying a policy to them. So they can have access to my bucket. And then within a bucket, you can't create a bucket within a bucket, but you can create subfolders if you wanted to. I think you can create policies that only give permissions to a subfolder within a bucket. Yeah.
So
that would be my guess. Yeah. But it's proprietary, right? So not sure. Okay, great. So I think what we're going to do is we're going to skip the versioning demo. And we're just going to go straight into the deploying static site one. The slides are here that have the walkthrough. So feel free to take a look at that. So what we're going to want to do, most of the static part is the same actually. So we're going to want to click on services and then click on storage at the bottom. And then S3 here. So this will open up the S3 dashboard. And okay, we don't need that. We're just going to press create bucket to create a new bucket. And let me just pull up. So just make sure I don't do anything wrong. So we want to give our bucket a unique name. For example, we can go with my bucket and see what ends up happening. I'm certain that one's taken already. We can leave these settings as default. If you're interested in learning more, feel free to ask me afterwards. This one we have to turn off because we want to host a website here. So we want people to have access to it. So we're just unchecking the block all public access, right? We want people to have access. And then we have to check this acknowledge. And then let's enable versioning. If we get around to it, we can do the versioning part. And then we're going to leave default encryption on. And then, yeah, we can leave it at that. Let's just click create bucket. And yeah, as you can see, it's saying the name is already there. So we'll just add a couple of numbers here, like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'd hope that this is okay, looks good. Yeah. I think there's a length of the name too. It's like 64 characters or something. So theoretically, eventually they'll all be taken. But by then, presumably there'll be a work plan. Okay, great. So we have our bucket. Now, how do we use it? How do we get our site up there? Well, the first thing we have to do is change the permissions slightly. So we're going to click on permissions and scroll down to bucket policy. Here, we're doing that thing where we give the badge to a computer. We're giving it to a service. We're saying this service now has access to do something. So we're going to go back to the slides actually, and then just copy the policy document. So it's sitting right here. And it's actually very similar to the one we talked about. Super. We're basically just giving permissions to, so this has a notion of a printable. We won't talk about that too much. We're giving the get object permission. So this is essentially equal to read access for all buckets. So here we need to change this part to match with our bucket name. I'm just going to copy it here. And then zoom out. Any questions on that so far? Okay. And then we want to click Save Changes. So when you click Save Changes, AWS will automatically validate the policy, make sure it's formatted properly. And then if everything looks good, it'll add it. Okay, great. So that part has been done. Let's go over to properties here and then scroll down to the bottom. And we want to click on this static website hosting part. So if we click edit, we want to enable this. And this just tells S3, hey, recognize the data that we're going to store as a website. And it lets us specify the file to direct the website to when it's first, like when you first look it up. So we're just going to write index.html because when we build the default React app, by default, that's what the like the page is called. And then we're going to, just for completeness, we can add it there. This part isn't strictly necessary for the error document. The index document is the most important part. We're just saying, go here when somebody tries to access the website. Any questions on that? Okay, so we'll just save that. And now I think our bucket should be configured. All we did was added the permissions and then said, hey, look for the index.html. So what we're going to do is we're going to go over to the to a text editor. In our case, we're just going to use Visual Studio Code. That's the one that we recommend. So if you're looking to do this yourself, strongly recommend getting that. And then we're going to open a new folder. So that can be done by clicking File, Open Folder. And then let me go over to, I guess I'll create a new folder here. Hold on. Demo. Okay, so I'm just creating a new folder. Going opening the editor in that folder. And we can see on the left, there's nothing in the folder. So if I open the terminal by clicking Terminal, New Terminal, this will open a little command prompt. And then again, to follow with this demo, you're going to have to download Node.js. So the link for that is also in the slides. But if you follow through with any of our previous workshops, you should be good to go. So here, what we're going to do is we're going to just create a default React app. So I'm not going to get too much into React because we've talked about it in the past. And frankly, we just don't have the time. But the command here is just npx create React app with the items. Oh, thanks. Okay, hold on a second. Do you know how I zoom? Zoom in, let's try that. Okay, that seems to work. Can you guys see this okay? Or would you like me to try zooming in some more? Okay. Let me open up a new terminal. I'm not sure, this one is kind of bugging out. Okay, all we need to do here is run the command npx create React app. And then we have to give it a name. So we're just gonna, we can call it whatever we want. I guess we'll just say HackCloud demo. And what this will do is it'll take a second to run, but it's going to create a folder here. And then under that folder, it's just going to create some default files for a website. So I already have one open. So we'll let that run and I'll show you that it looks the same. But this is what it looked like after it's added all the files. So here I'm going to open a terminal again. And then I'm just going to run the website to show you what it actually looks. So we can run npm start, just like we've done in the other workup series that we've given. And then it'll take a second. And it will run our website locally on my own computer. So once it's done that, wait a second. Two. Okay. Once it has done that, though, it'll open it up and it'll be a little spinning React logo. Got it. Okay, there we go. It looks like it's working. It's just giving some warnings. Give it a second. Okay, there we go. Come on. There you go. Okay, so it says like you can view it in the browser with this link, right? So I'm just going to hold control and click the link. Well, I could also copy and paste it, and it'll just open it up for me. Okay, great. So we see the logo is spinning. It has the default stuff. Any questions on how we were able to get this far? Okay, great. So let's now work towards actually like putting this website online, right? So people can see it. What we have to do is run the command npm run build, and this will go ahead and build the app. So what that means is that it's just kind of packaging it together in a like an optimized version, so that it's expected once you have that, you can actually put it somewhere else. So it'll actually save the files in this build folder. If I open that, once it's done, the files will be in there. Let's give that a second. And then all we'll need to do is just copy and paste those files into S3, and then we should be good to go. So not too tricky of a process once you've configured your environment. And assuming you have time to wait. Okay, great. So you can see it's filled up a bunch of files here. We can also see there's an index.html file, right? The one that we told the S3 bucket to redirect to. So to do this actual upload, I'm going to right click this, click reveal in file explorer, and then go inside the build directory, and then select everything. And then if I hop back over to S3, I can click on objects and then upload. And then I can just drag and drop. Drag and drop like that. And then just click upload at the bottom. All right, and if we let this run, it should not take long. Yep, we just click close. And then to actually view our website, we can click on properties and then scroll back down to that section to edit the static website hosting. And then hopefully you did everything right. You just click this link and you can see we have our website. It's been deployed. So if you go to this, if you copy this URL into your browser, you'll be able to see it as well. So yeah, go ahead. Did anyone have any questions on that? Okay, great. So we went a little bit over. Let me quickly go back to the slides. I think we have one or two small things that we wanted to say. Okay, this is the demo slides. The feedback form again. We really want to make sure we can get through to you guys for future meetings. We wanted to get it this time, but didn't really end up working out. But make sure you fill out this form so we can do that. Free stuff is always good. If you want, the QR code is also on the slides. So yeah, really do try to do that. And hope that thanks for coming out. Hopefully you learned something. Our next workshop will be next week, but it'll be an hour early, 6:30 to 7:30. We don't actually have the room for the normal. And we'll be going over virtual machine computing. So the demo will be a little bit more in depth if you were looking for something a little deeper. Yeah. Other than that, have a great rest of your night. And if you have any questions, feel free to just ask. That was good.